All right, so this is the start of pre-calculus, and I always like to start by talking about our parent function. So this first lesson's dealing with the parent function. Now over here on the sheet, I have this as an attachment, so you should be able to pull this up full screen. I know with the split screen, it's probably kind of small, but we're looking at these today. We're maybe one or two exceptions. Hopefully, for the most part, they look familiar. A few of these are going to look very odd. So for instance, that one right there probably does not look familiar. We don't use it much. We're not going to use it much in this class today, this year either, but it is a function. We'll talk about it later. The other thing that's a little weird is that really these two, rational, reciprocal, are two names that mean the same thing. They both mean this one. So you don't really need to worry about that graph or that equation. All right. Now, we most definitely will be using those bottom three in this class. However, we're not going to see those until we get to chapters 4 and 5. So for our purposes today, you don't need those, but they definitely will be important in this class, just not for our first couple of chapters. We're not going to spend any time talking about those today. We're going to spend a lot of time talking about those when we get to chapters 4 and 5. All right, so today we're looking at the remaining ones. So the first one is f of x equals a. Whenever we see a, it always refers to a constant, meaning this could be f of x equals -3, f of x equals 5. In this specific case, it refers to f of x equals 4. So they give you the graph of f of x equals 4. The point is that f of x equals a certain number. Also, all of these say f of x. Remember, you can always substitute y. Y equals 4, y equals x, y equals absolute value, so on and so forth. F of x and y we can interchange. Okay. The next one's linear. You spend like algebra 1 talking about linear functions. We can do slope, y-intercept, etc. Our basic linear one is f of x, or y equals x. It goes through the origin and has a has a slope of 1. Now, linear is actually where we get absolute value from. Remember, absolute value just makes something positive. Absolute value is the distance from 0, and distance is always positive. And so absolute value and our linear function are exactly the same until we get right there. And then once we get there, linear goes negative, and absolute value is like, well, I can't be negative, I have to be positive. So we just flip that end up and change all those negative values to positive values, and that's where we get the absolute value graph. We'll come back and talk about greatest integer in a second. Quadratic, hopefully you spend a lot of time in algebra 2 talking about quadratics. This shape right here is a parabola. Cubic is a lot like a parabola. The only difference is for the parabola, they all get positive values, because when I square a negative number, it becomes positive. But when I cube a negative number, it stays negative. So that's why it's kind of like a parabola, but that second half of the parabola's been flipped down. A square root is a parabola flipped on its side, and then we just only have one half. So if I think about this as a parabola like that, I just take off that half and I'm left with that. So it's different because it starts here, but then goes forever in that direction. And then a cube roots, well, think about this as I had a parabola, but then I took this part of the parabola and flipped it about the y-axis. That's what I would get. Right? We're going to spend a lot of time talking about exponential and logarithmic. I don't say that a lot of times. We'll spend a chapter talking about those. Hopefully you've already talked about those in algebra 2, but that would have been the first time you saw those. We'll see them again here. What you really need to know is that they go together. They're inverses of each other. And so if you think about the line y equals x, which is that one right there, they're symmetrical. So if I graphed logarithmic on this, there you go. They're symmetrical about that line. The most important thing for today that you need to know about exponential is that it always crosses the y-axis At 1, it never touches the x-axis. It gets closer and closer to the x-axis, never touches it. Logarithm, it works backwards. It crosses the x-axis at 1 and never touches the y-axis, just gets closer and closer to it. All right, and then we get the reciprocal one, which just looks weird, has a vertical asymptote. We call this graph a hyperbola. So it gets closer and closer to both the x and y axis, going those 2 different directions, but again, never touches it. All right, so those are those. This is what we're going to do. Pull this up. What function? So I'm going to pull up a function. We'll do one with their paper, right? All right, so this one right here, and then ask, what is the equation and what's the name? All right, well, here we're looking at our paper. So I'm looking at my paper saying, okay, which one matches that? Well, that one, thought I was draw. That one does. And so over here, I'd write, all right, it's quadratic, and it's f of x equals x squared. Okay, now that seems simple enough, but this is the catch. We're going to try to do this without the paper. Okay, so this is what I want you to do. I want you to pull up the paper on your screen. I'm going to make, all right, let's see here. I'm going to make this full screen, right? So the paper, the parent function is not on my screen right now. So I want you to look at the paper real quick, and then I want you to put it away so you're not looking at it. Don't cheat. I'm going to flip to our next slide, and I want you to try your best to come up with what's the equation and the name of the function. All right, so here we go. So without looking at your paper, come up with the equation and name of this function. If you're not sure, just give it your best guess. All right, and then you will most definitely have to be pausing the video because I'm going to go fairly quickly, but pause the video, give it on your paper, even in your head, whatever, just give it your best guess, right? Well, this one, if you came up with, was, flip back to my paper now, absolute value. So that right there is what you should have had for this one, okay? So pull out your paper, look, give yourself a chance to look at each one, see if you can kind of quickly memorize-ish them. Then whenever you feel ready, put it away and try the next one. Right? So pause the video, write what you think this is, and then we'll go over it. All right, so this one is linear. Now, I know the graph doesn't look exactly the same. This one's been transformed, but the parent function is linear, okay, which is f of x equals x or y equals x. All right, so we're going to do a few more. I'm not going to keep pulling this up because I know you can just pull the paper up and figure out which one it is. But each one I show, I want you to look at your paper, then put your paper away, and then try them. And after a while, you might be able to try several in a row without needing to keep pulling your paper out over and over again. All right? So, all right, pause the video, try it, and then whenever you are ready, you can hit play. All right, so this one was cubic, f of x equals x cubed. All right, try this one. Right, this one was this one's either rational or reciprocal. Both names work, and the function is 1 over x. Pause the video and try this one. All right, this one was a square root, and it was f of x equals the square root of x. All right, pause the video, try this one. All right, so this one, I said I was going to talk about it now, later. Oh, we got it later. So this one is the greatest integer. Integer function. And so we can say f of x equals, its correct notation is kind of like a double bracket x. Sometimes you'll see a single bracket, but a lot of times we'll put like double brackets to show this function. But if you look on there, it also had this int x. This is what it looks like. That's what it looks like if I was to try to do this on my calculator, which my graphing calculator will graph this, and that's what it looks like on the calculator. But this double brackets the proper notation. Now, what is it? What's it doing? Now, kind of just based on appearances, this function is also called the step function, just because it looks like steps. Greatest integer. So greatest integer, remember, integers are whole numbers, positive, negative, or zero. Okay, so how we do this is we come up with an x value. Let's say I have an x value right here. Probably should use a different color. We'll use blue. This x value right here. Let's say that x value is 1.3. Okay. We ask, what is the greatest integer without going over 1.3? Well, again, my integers are -1, 0, 1, 2, 3. So what's the greatest integer without going over? Well, 1 is less, 2 is over. I can't go over. So the greatest integer would be 1. So I would come up and put a point at a y value of 1, which is where it is. Well, if I came color, do darker blue. Come over here. We'll say this is 1.9. Well, still the greatest integer without going over is still 1. So we'd put a point at 1. But then once I jump up here to 2, once I'm at 2, the greatest integer is no longer 1, it's 2. So we jump up to 2. And that every single point along here, the greatest integer is 2 until I get to 3, in which case I jump up here. So the open point here shows that we go all the way up to 3, but once we hit 3, we jump up and hit 3. So that's why it has the little step function deal, why it looks the way it looks. All right, so there you go. There's my little tangent on the greatest integer. All right, pause the video, try this one. All right, so this one is our exponential. Now, I don't think I pointed this out, but I think yours says y equals a to the x. And so, for instance, this could be y equals 2 to the x, or y equals 3 to the x, something like that. Okay, this is specifically is y equals 2 to the x. Okay, but it's exponential. Right, pause the video and try this one. This one is logarithmic. The function itself's a little weird to write. So log base a of x. That's the logarithm. All right, so switching gears. I'm going to pull your paper out and look at it before you move on. But what I'm going to do is I'm going to pull up the name of a function now. And what I want you to do is just do a little brief sketch of the graph, just like what the graph looks like on the paper. Okay, so kind of working backwards. So look at your paper or pull it up on your computer screen. Pause the video while you're doing that. And then whenever you're ready, hit play, put the paper away, and we'll do our first one. All right, so the first one, quadratic. So best as you can, try to do it without using your paper. Draw the graph of a quadratic. All right, so a quadratic should look like that. Basic graph for a quadratic. All right, linear. Pause the video and try a linear. All right, linear should look like that. All right, pause your video and try to do exponential. All right, exponential looks like that. Kind of hugs the x-axis, maybe a little closer than I drew it, but it always crosses the y-axis at 1. All right, pause the video, try absolute value. All right, so absolute value, it's going to look just like the linear function, except once I get here, it shoots out there, so it looks like a V. All right, pause the video and try this one. So logarithmic's the inverse of exponential. So instead of hugging the x-axis, it's going to hug the y-axis. It's going to cross the x-axis at 1 and just kind of go up. All right, now I know this one's hard to do, but just best you can. Pause the video and try this one. All right, so let's see how well I can do on this one. So close point on the left, open point, we'll say that's at an x value of 1, and then it shoots up here, we'll call that a y value of 1. Close point, open point. Close point, open point. And it goes backward as well. Open point, close point. All right. And that would be a graph of greatest integer. All right, go ahead and pause the video and try rational. So rational kind of hugs the x-axis and then the y-axis, and then comes down here, hugs the y-axis, and then the x-axis. Something kind of like, oh, sorry, nope. I did that. Probably yelling at me through the video. I did that backwards, didn't I? There we go. So on this quadrant and this quadrant. There we go. That's correct. Square root. Pause video, try square root. So square root's kind of the weird one, that it starts at a point and then kind of a half a parabola going off that direction. All right, perfect. So homework. So this should be attached. Let me explain this. This should be very simple. You can very much use your paper on this. Don't expect you to try to memorize. The only reason we went through that whole process with that paper and trying to do all those things without looking at the paper is, as we go throughout this class, you really do need to know your parent functions. You need to be able to see a graph and know what parent function it makes, or see a function and know what the graph's going to look like. And so that's why it's really important to know those. And that's just the best way I've found of teaching right off the bat. about the parent functions. So on this, if you want to try this without your paper, great, definitely do so. But what you're going to do, I'll do example for each section. It says name. Now they don't look just like the parent functions. You need to figure out which parent function family. So for instance, number 5 is an example of the rational or reciprocal, whichever name you prefer. They mean the same thing. Okay. Draw the basic graph. Now, don't stick these in your calculator and graph them, because that's not the graph we want. We want the graph of the parent function, meaning the graph that looks like it's your paper. So for instance, number 12 is a quadratic. So my graph for number 12 is just going to be that. Okay. Number 13, it says, give an example of a parent function, or sorry, of a function in the parent function family of each one that's not like one above. So let's see here. I'll do absolute value, the first one on the list. Now, some absolute value functions. There's an absolute value. There's an absolute value. There's an absolute value. So those are examples, but they said do not use any of those examples. Do something else. So you need some absolute values. Let's throw some numbers in. We'll say x plus 2 minus 5, and maybe put a 3 out front or something like that. Don't use that example. Make up your own, but that's what you're doing for all of those. Okay, there's that section. Number 18 through this section, all you're doing is saying what the name is. So for instance, 19, the name of that one is linear. Okay, and then for 22 through 24, make up a real life example of each of the following parent functions. And this says hint, why don't you Google these. So what is something in real life that actually that these functions can model, right? So go ahead and try that. I won't say which one they go with, but the spread of a virus, a projectile, throwing a ball, things like that. Those would be examples. I'll let you figure out which functions those model, or come up with your own examples, but come up with an example for each one of those. All right, and that's it. I'll see you at 1.2.